Hello and welcome to Physical Science. This is the recording for either 8:14 or 8:15. That would be Wednesday or Thursday, so this is for the block class. And I'm making a recording because Jigsaw is not yet recording things. All right, so I'm going to work on the important things that that we went over in class that will help you to understand the material. So here's the first thing we did, which is the knowledge check. So take a second, hit pause, and read through this and choose your answer. All right, so make sure you pause, and here comes the answer. So the main thing here you want to look at is it wants you to know which two atoms represent the same element. So that's our key word there, is the same element. And what has to be the same for every atom of an element? Are we looking at the number of electrons? We're looking at the number of neutrons? Or are we looking at the number of protons? If you said proton number, that is correct. The number of protons is what tells you which atom you have, which element you have. And are the number of protons, is that the atomic number or is that the atomic mass? And it is the atomic number. And so that is the number that is on the periodic table. So here's my periodic table. So like hydrogen is atomic number 1, lithium is 3, and this one here is number 19, which is potassium. All right, so these are two atoms of potassium. They are the same element. They are both potassium because they both have an atomic number of 19. They both contain 19 protons in the nucleus. So the answer was W and Y. So okay for the answer. And if you have any questions, just pick up the phone and call me, or you can send me an email. Either way is good. Let me move on to the next slide here. We have one more knowledge check. So again, pause the recording and read the question and determine your answer. All right, so now I'm going to go over the answer. I'm going to cross my fingers that annotation works. And no, the annotation is not going to work on this one. It didn't work on this slide all week. Okay, so it basically is saying, look at the models, right? And which one, here's my little pointer, which one, look at the models, and these atoms exhibit similar properties. They do not have the same mass, and this is their mass here. This is carbon 14 is the mass number, 13 is the mass number, and 12 is the mass number. So which of these best describes the atoms in Marla's model? And the way I looked at this one is I looked at eliminating answers instead, because if you have no idea, you want to eliminate answers. And I'm looking at this one. The atoms have different number of protons. And I can see very easily up here that they all have 6 protons. So I can eliminate that one right away. Same thing with the turtle. They have different number of electrons. And it might be hard for you to see this, but these little blue dots are the electrons. And there are 6 of them in each picture. So they do not have different numbers of electrons. So the turtle is out. And then as far as the smiley face, remember to make a different ion. Okay, so when we have equal numbers of protons and electrons, the atom is neutral. And to make an ion, you either have to have additional electrons or you have to take electrons away. If you have additional electrons added, you become negative, a negative ion, excuse me. And if you have lost electrons, then you become a positive ion. Since these all have equal numbers of protons and electrons, then these cannot be ions. So even if you don't know what an isotope is, you have no idea, you can get to that answer by the elimination. So what is an isotope? An isotope is an atom of an element that has a different number of neutrons. So it might have the same number of neutrons as protons, or it might have more. It could possibly have less, but generally they are unstable if you have too few neutrons, because neutrons are what glues the atom together. All right, moving on. So today's lesson is about periodic table and how it is arranged. We're going to look at the trends. The lesson examines the history, describes the organization, and tells you a little bit about how to come up with the properties based on the periodic table. All right, so let me just give you a little background and then I'll send you off to do the lesson. The periodic table is organized by increasing atomic number, and you can see that by hydrogen being number 1. Then we go across, helium is number 2, and then it starts repeating when we have properties that repeat. So we go back to this side and we have lithium is number 3, beryllium is 4, it goes across. Oh, now neon and helium have similar properties. They are unreactive, and then it goes back and starts over because sodium and lithium have similar properties. So they put those in a column, and those columns are called groups. And the thing that makes them have the same properties is the number of valence electrons. And valence electrons are the electrons in the outermost level of the atom. So if we go back to our models here, you can see that carbon has 2 electron levels. And that is because it's in the second period of the periodic table. Carbon is over here. And you can see helium is the first period, and then carbon is down in the second period. So therefore, it has 2 electron levels, and it has 1, 2, 3, 4 valence electrons. And it has 4 valence electrons, just like the rest of its family. And it's really nice on the periodic table here because the group number is 14, which ends in 4, and so that way you know it has 4 valence electrons. For example, group 13 will have 3 valence electrons. So how many valence electrons do you think group 15 will have? Well, if you said 5, you are correct. What about group 16? And if you said 6, you are correct. So it just goes along with the group number. And the maximum number of electrons, valence electrons you can have, I'm trying to make sure I can see, I show you the right thing in the camera. The maximum number is over here in the last column, and that's going to be 8. So when you have 8 valence electrons, that electron level is full, and you're very, very stable when that outer electron level is full. Okay. I think I covered everything on there. Oh, yes, as you go across the periodic table from left to right, the mass increases and also the atomic number increases. And what particles make up the atomic number? And if you said protons, then you were correct. The protons determine what element it is, and it's called atomic number. Both of those things also increase as you go down. The atoms get more massive, and the atomic number increases as well. All right, so in class, we had a little bit of time, or not so much time, to go through the periodic table lesson. I did answer some questions. We're going to recap here. I'll let you read my, my summary, and you can email or call me with any questions you have. And then I've got a little interactive to show you. So let me scoot over. Oh, the place where you will find your lesson, first you go to Canvas and you click on my course, which has a picture of Neil deGrasse Tyson, and he's kind of bobbling around, and then it says science. All right, and then you click on modules on the left once you get to my course, and then you scroll down, 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 till you find today's date, or the 14th and the 15th date. Yeah, and there's no more grayed out anything, so just ignore that. Okay, and so here is my recap. So go ahead and pause this, read over this, and if you have any questions, put them in an email to me, or write them down and ask them in class next time, or give me a call, and I'd be more than happy to go over those. All right, the last thing that we're going to do today is we are going to build an atom. So I put into Google PhET, P-H-E-T, build an atom. And so if you would go ahead and pause this and do that, and then once you find it, it's this one, phet.colorado.edu with the simulation. And this is what you should get. Oops. We're just going to play it online. All right, so this is what you should look for. So go ahead and pause it and search for PhET, build an atom, and then come on back. All right, so we're going to click on the atom, and we're going to click on the green button, net charge. We're going to click on the green button for mass number, and I'm going to click on stable or unstable, and I'm going to toss a proton into the middle. You can see it is hydrogen. The element shows up here, and I wonder, oh, that's not what I meant to do. I meant to put my video on so you'd still be able to see me. Let me share back. So, oh, why my video is not working there? Anyway, so I've got my hydrogen in the middle. You can see that it created a net charge of +1, and it has a mass number also of 1. So the net charge is +1 because this is a proton, and protons have a positive charge. It's really annoying that that my video isn't working. I'm going to turn off my webcam and my other one. Anyway, sorry about that. So I'm going to go ahead and add a neutron now. And so notice that my mass number went up to 2 because the mass number is the mass of the nucleus. It includes both protons and neutrons. So that is 2. The net charge is still +1 because the neutron is neutral, so it does not affect the charge of the atom. So what can I do to neutralize the net charge to get that to 0? And hopefully you said to add an electron, because every negative electron will balance out a positive proton. So there's a plus for a minus. Nicely balanced, our net charge is 0. And we have a stable hydrogen atom. So how many protons would I have to add to get here to lithium? And if you ever need more time, you just hit pause on the recording. And if you said 2 protons, then you are on the right track. 1 more proton would give me helium, and a second one would give me lithium. And oh no, we have an unstable isotope. What can we add to stabilize this? The protons need to be balanced out by neutrons, to stabilize it. The neutrons are like nuclear glue, and they hold the protons together, keep them balanced and together there. So let's see. Lithium is in group 1. So when it's neutral, how many valence electrons should it have? It's in group 1. Remember, the group number tells you the valence electrons. So it should have 1 valence electron. And you might say, well, it does have 1 in the outermost level, but it's not neutral. How many electrons do we have to add to make this lithium neutral? And if you said 2, then you would be correct. And there's our neutral atom. And how many valence electrons does it have? How many electrons in this outer level? Aha, it has 1. And remember, the mass number is the number of protons plus the neutrons. So we've got 3 neutrons and 3 protons for 6 total. You can probably add another neutron. That makes another stable isotope of lithium. Let's see if there's a third stable isotope. Nope, that was it. So this is an unstable isotope. There are too many neutrons. If we add those up, though, we've got 5 plus 3 gives us the mass number of 8. All right, the last one I want to make for you is oxygen, because I really like oxygen. It's very useful to our life, since we need it in order to make energy and for respiration. And I'm going to add, what am I going to add to stabilize it? Right, I'm going to add neutrons. Oh, there's my video. Aha. Okay, so I'm going to add some neutrons to make it stable. Now, it says it has a charge of +5, and oxygen does not end up with a charge of +5, ever. Never do that. So what do we have to add to make it neutral? Giving you a hint there. So I'm going to add some electrons, and I'm watching this to make it neutral. Every time I add one, the charge goes down because electrons are negative, so we subtract the electrons. So to get the net charge, we take the number of protons. Whoop. Oh, it's so weird with this. We take the number of protons minus the number of electrons. So protons minus electrons will give you the charge. Protons plus the neutrons will give you the mass. Okay, so those are 2 good little equations that you need to remember. Now, oxygen in group 16, how many valence electrons does it have? And if you said 6, then you are correct. There are 6 electrons in the outermost level here. So it has 6 valence electrons. To be a very stable ion, it wants to fill up this outer level. So do you remember how many electrons that an atom wants to have to be stable? You said 8. So weird with the grass background. If you said 8, then you are correct. So to make this a stable ion, we're going to have to add 2 more electrons so that it has a full outer layer. That's called an octet. Kind of like an octopus has 8 legs, an octet has 8 electrons in the outer level. So that is a stable oxygen ion. All right, so if you have questions, put them in an email, call me. And the next thing you want to do is you go onto yours and play around a little bit. And then there's this game at the bottom. And this game is really good for you to learn this and practice this. And this is the game you want to play. Whoops. This is the game you want to play with the balances. Once you've been through that, You can certainly try the other ones as well. They're all good, but this is the one that covers what we're doing right now. And then once you have finished playing the game a little bit, then come on back to the recording. You're going to pause it, you play the game. And if you do play it more than once, it'll give you new questions. So you're welcome to play it more than once. And then come on back when you're done playing the game. And then I will recap today's lesson. I need to pause this. Pause recording. All right, I'll be back in a sec. Hey, welcome back. I just wanted to make sure you saw the original slide that went with the build the atom. And then I wanted you to make sure and have the slide with the game. And then I want to go ahead and recap. So here's your knowledge check. Go ahead and pause this and think about it a little bit, and then I will talk about the answer. Make sure you see the hint over here that we're looking about the valence electrons. All right, so pause it. So here is the answer. Why would chlorine be looking for an electron? Well, if you look at the valence electrons of chlorine, you can see that it has 7 valence electrons. And if you find it on the periodic table, oops, on the wrong end, you'll see that chlorine is in group 17, and that means that it has 7 valence electrons. So it's looking for one more because all atoms, when they're forming ions, want to get to that octet, which is 8 valence electrons. So he's just looking for one more to get to that 8 valence electrons. And why does sodium have an extra one? Well, it only has 1 valence electron. So the easiest way for him to get to that full octet, that full 8 valence electrons, is to just get rid of that one little electron. And you can see that sodium is over here. Na is sodium, and that's over here in group 1. Group 1 has a 1 valence electron. And so all of these group 1 atoms, elements, are very reactive in their just elemental state. And eventually I'll show you a reaction of sodium and what it does. It's a pretty violent reaction, but really neat to watch. Anyway, one more question and then we will reach the end. What ion will chlorine and sodium form? So take a sec, pause this, see if you can figure it out, and then I'll give you the answer. All right, so the answer to the ion question, what ion will chlorine form? Remember we said it had 7 valence electrons. It wants to get to 8, right? 7 to 8. So how many did it gain? It gained 1 electron. Okay, so if you gain 1 electron, now you have a -1 charge. Because you have 1 more electron than you have protons. And sodium, conversely, it lost an electron because it has that 1 extra. And so now it has a +1 charge because it has 1 more proton than it has electrons. Remember, to get the ion charge, you take your proton number minus your electron number, and that'll give you the charge. So sodium is +1 and chlorine is -1. And you know what happens when sodium and chlorine get together? Sodium actually gives its electron to chlorine. And what compound is formed when sodium gives its electron to chlorine? And if you said sodium chloride, you are correct. And what is sodium chloride better known as? And if you said salt, you are correct. So that salt you put on your food that you use in cooking, that is how it works. Sodium gives up an electron to chlorine, and yum, there we have some delicious food. So that's it for today. Thanks for watching, and I will see you in Live Class Connect.